Well, we've been spending a lot of time learning all kinds of different methods to solve quadratic equations. Now, quadratic equations are just equations with x squareds. And, well, one of the first things we learned when we started the chapter is that x squared is always going to make a parabola. I want to go back to the idea of graphing a parabola, particularly the vertex. And what you're going to find out today is that we have two ways that we can find a vertex. Yeah, you might like one of the ways over the other, but the whole point is that you really realize that they both give us the same answer. So we're going to make a little connection as we look at, again, the vertex. Now, do you remember the first method for finding the vertex? Yeah, it's this formula, the opposite of b over 2a. And the nice thing about that formula is, well, it's a formula. And all you got to do is plug in, well, b and a. Of course, b and a end up being the numbers that are part of my equation over here. So let's get to it. Let's find the x value being the opposite of b, so the opposite of 4, over 2 times 1. Looks like that just comes out to negative 2. That was pretty fast, and it's supposed to be. Here's the part that's a little bit more of a pain, trying to find the y value. Of course, y values always come from plugging in x values, so I'm going to plug in negative 2 back into this original equation. Got to do the math carefully. If you do it carefully, you end up getting 4, you get negative 8, and plus 8, so okay, it's not too bad, it just comes out to be 4. The point, negative 2, 4. Now, that should be our vertex. In fact, it is. But let's find that vertex using this new method just from a few days ago, completing the square, it's called. Yeah, what is this completing the square thing? Well, it's taking the equation that we have here, this x squared plus 4x plus 8, and it's making it, well, it's making it perfect. It's actually adding in just the right number that will make it perfect. But we have to understand that if we're going to add in a number, then we actually also have to take it away. This is the part that, quite honestly, I can understand if it's a little confusing, but just work with me a little bit here. We need to add in the right number. But if I'm going to add something, I got to also take it away so that I keep the equation balanced. Now remember, I need half of this number, that's the number 2, squared. It's always half of that number squared. Well, that's the number 4, and that's our magic number that I want to add into the equation, but it turns out that I also want to subtract, again, to keep the equation balanced. So what does this do? Well, it allows me to rewrite the problem as something squared. By the way, 8 minus 4 out here needs to be simplified, and it will happen to simplify to be plus 4. But the most important thing here is that we realize that this part can be written as something squared. Yeah, it's x plus 2. Well, we just changed this equation, that is this original equation, we changed it to what's called vertex form. Why? What can we do with vertex form? Well, remember, it's called vertex form because it helps us to find the vertex. Remember, if I have a plus sign here, that actually means I shifted to the left 2. And if I have a plus sign here, it means that I shifted up 4. Oh, look, that's the same vertex that I found with my method 1. And that's the way this is supposed to work. I should be getting the same value. Now I can graph it. That's kind of why we found it in the first place, so I can kind of estimate negative 2, 4. It would be nice if I had another point to plot. How about the y-intercept? You remember how the y-intercept is the number at the end? That's because I can plug in a 0 very easily and arrive at the number 0, 8. And then it wouldn't be a bad idea to get a symmetry point. The symmetry point's got to be balanced with my vertex, so it's going to be over here. That's right, it's going to be across from the y-intercept. But again, thinking about a balance, we need to double negative 2. If I double negative 2, that is the line in the middle, I get negative 4. But again, it's still 8. I think I got a parabola. It's going to pass through the y-intercept. It's going to dip down to the vertex, and of course pass through my point of symmetry. The whole point today is to honestly try this new method. It's called completing the square, and it doesn't have to be scary, intimidating. It's just new. Now, it's usually helpful when the teacher shows you that we want to add in some perfect number. And you notice that I always add that number in right beside my x term. Now, that plus 7, yeah, it's still there, but beside it is going to have to be the opposite of what I'm adding in, so I'm going to have to subtract something away. Are you thinking of half of 10 squared? Yeah, that's the perfect number that I'm going to add in and subtract away. Once I have added in and subtracted away 25, once I have done that, I can now write the problem as something squared. By the way, being careful with my math here, I'm going to end up with negative 18, right? So, you know, that's a new number, but what is it that's being squared? That's right, it's x minus 5. X minus 5. You just completed the square. We just wrote this problem in vertex form. And what can we do when we have the problem in vertex form? We can very easily find the vertex. Now, please get this part right. Remember, when you have a number on the inside, it's the opposite shift. And then this number at the outside, of course, is going to be my vertical shift. We're not going to bother graphing that one. The whole point was to just find the vertex. So, can I do this with a quadratic equation that's, well, a little more complicated? It's got some more numbers. Basically, it's got a coefficient. The answer is yes, but I got to be careful about the coefficient because I haven't told you, but you can only do this thing called completing the square if the coefficient's 1. Okay, now remember I just said we can still do this problem, but we got to do something with the 9. Now I can't just like erase it, but I can factor it. I can basically take out the 9. Notice that I'm going to take that 9 also out of the 18. Now, here's the deal. Beside this 2x is where my perfect number goes. And, well, that minus 3, it's still part of this equation, but it's kind of at the outside of all this funny business. So I factored out a 9. It changed my terms a little bit. I still have a space for that perfect number. Oh, yeah, are you kind of saying, Miss Naylor, you got to subtract a number? You're right. I have to subtract a number if I'm going to add a number. So, half of 2 squared. Yep, it's the number 1. Now, here's the part where I want you to focus with me a little bit. I didn't actually add the number 1 into this equation. Say what? Let me say it again. I did not add the number 1. I actually added 9 times 1. You see that number that got factored out? It's going to also affect, it's going to be applied to that 1. So that means I added 9. That's right, I added 9. So that means I need to subtract 9. Careful, that might be the trickiest thing all day, but it's correct. It follows the algebra. Remember, I can write this as something squared. By the way, negative 3 and negative 9 become negative 12. But on the inside, I want to think about what it is that got squared. And of course, that is x plus 1. Why are we doing this? It's so I can get the vertex. It's supposed to be easy to get the vertex when you have vertex form. Vertex form is when you can just quickly think about shifting. And bam, I got my vertex. You say, what about this 9 out here? Well, it doesn't affect the numbers on the inside, so it's not going to change my vertex. But what it is going to do is it's going to be a stretch number. It's going to stretch my parabola. Now remember, it's going to stretch it because it's such a big number. It's a number that's greater than 1. Let's graph the vertex. Let's graph -1, -12. Let's also graph the y-intercept. Okay, by the way, it's still easier to find the y-intercept back here with the standard equation. So I'm going to just kind of circle -3 because I know that that's the y-intercept. And then my symmetry point, it's got to be over here. It's going to be at the same height as -3, but it's got to be double my vertex. Now, what do we got brewing here? Well, we got brewing a stretched parabola. A stretched parabola is going to look very tall, very stretched, very vertical. Okay, technically, that's what the number 9 technically has done to this problem. Okay, again, it has stretched it. So, the 9, I factored it out. It got applied to the number that I added in, because making it that I did not actually add 1. I actually added 9, which is why we had to subtract 9 just the same. I think there's a problem on the next page here that is meant for you to kind of try to see if you can go through the steps when you have a coefficient. So you can see that I factored the 2 out already. Are you thinking about what would be on the inside? You should have factored out a 2, reducing a bit. The minus 8 becomes a -4. Am I still going to be adding some number in here? I am. It looks like that I actually have a space for that down here. So I'm adding in a number, and as you can see, I'm also subtracting a number. It's going to be half of this number squared. So half of -4 is 2. Squared does come out to be +4. But remember, I didn't actually add +4, so please don't go over here and put a 4. I actually added 2 times 4. So I have to take away 8. So what do we got? We've got something squared. It's always the x and then the half number, so that's why it's a -2. Squared, I've got this square up here, which is important. And then it looks like that becomes -5. Maybe it would be better if I just had a -5. But either way, it's either plus -5 or -5. So I'm ready for a vertex, right? If you have a minus sign, that actually shifts to the right. If you have a minus sign out here, it does the same thing. So I have 2, -5. Completing the square. It's an interesting way to find the vertex. It changes the equation, and it's a technique I would like you to practice as part of Algebra 2.